And then if you have the land use classifications, what is the important thing for you? So first we require to create training polygons, and then we need to select bands for classifications, and then we divide the training polygons for classification and validation, and then we have an algorithm to train the classifier, and then we have a classifier tuning, and then finally we have the classification of image, and we give a color palette to the different classified image, and then we visualize the result and we just export the classified image. So this is a step-by-step process what we follow, and I'll show you how it can be done. So we are not still dividing the training polygons for classification validation. I'll show you how it will done, and I hope you are okay with it because it's a time-taking process. So it's still running, so I'll show you how to it's done, it's done. So just open in Drive. So it's my class 2, we have the folder, and you just download it. Yeah, it's downloading and it's downloaded. So I have already opened the QGIS file and open my raster data. So I'm showing how it can be done. Open the raster data, downloads, land cover, add it, close. So this is exactly what I have done. So just go to this symbology, click this single band pseudo color, and go to this color bar and give the spectrum color. No, the same spectrum, right? Or or give a turbo color and just click apply. Just click apply. So this is the value range of NDVI from -6 to -1. So or else you just want to give a -1 value. Just clear this, give -1, and just clear this, give 1, and you just give a different color value, just greens, and you just apply it. This is how it comes. Or if you don't want everything, uh, go to palette or unique values. You just classify it, you'll get only one value, so it is won't have worked. Only go to this single band pseudo color, and you have a lot of things. So you just go to equal interval or quantile thing. Still, we have a lot of things. You just I need only, let's say, three classes, not more than that. I'll choose my own color. Let's say minus value, I'll give blue color. Let's already use it colors. I don't have any previous colors. Okay, let's say I use this blue color. I'll use this red color. Okay, red. I'll use this green color and apply it. Okay, it become only red. So this is how you can export the data into QGIS and apply whatever color you want. Let's say adding this number of color. Let's 5. Just apply it. Let's see. So if you increase the classes, then you will able to find. So this is how you can be doing the land cover classification using what we call QGIS. Or if you don't like the color, all color ramps, you can choose any one thing here. So you can choose anything. And if you want to create a new color thing, go to here, go to CPT city, click OK, and you will get different color options. It's taking here the different color option, greens, this thing, and okay, apply it, and just apply. Okay, it doesn't show. This is how we can do it. Okay, so till now you have understood, right? Hello. So like there is no doubt till now calculation of NDVI importing, exporting to QGIS and applying different colors.
Anaya,
Uh,
Anaya, అంటే మనం ఇక్కడ ఎన్డీఏ క్యాలిక్యులేట్ చేయడానికి ఇంకా అన్నయ్య
చెప్పు.
అన్నయ్య అంటే మనం ఇక్కడ ఎన్డీఏ క్యాలిక్యులేట్ చేసినాం కదా అన్నయ్య ఇంతకు ముందు. ఇప్పుడేమో ల్యాండ్ కవర్ క్యాలిక్యులేట్ చేసినాం కదా అన్నయ్య. అంటే మనం
ల్యాండ్ కవర్
రెండిటికి
ల్యాండ్
సేమ్.
కవర్ ల్యాండ్ కవర్ క్లాసిఫికేషన్ చేయడానికి ఎన్డీవై క్యాలిక్యులేట్ చేసాం.
ఓకే అని అంటే రెండిట్లలో మనం సేమ్ షేప్ ఫైల్ యూజ్ చేస్తాం కదా అన్నయ్య ఇప్పుడు.
అవును, ప్రతి దాంట్లో ఒకటే షేప్ ఫైల్. నేను షేప్ ఫైల్ ఎక్కడ చేంజ్ చేయలేదు. ఇగో ఏరియా ఆఫ్ ఇంట్రెస్ట్ అదే ఉంది మొత్తానికి.
ఓకే అన్నయ్య, ఇంకొకటి ఏంటంటే ఇప్పుడు మనం ఇక్కడ అంటే ల్యాండ్ సైడ్ లో కలెక్షన్ చేస్తున్నాం కదా అన్నయ్య. అక్కడ మనం సర్ఫేస్ రిఫ్లెక్టెన్స్ లో అంటే 2 టైర్స్ ఉన్నాయి కదా అన్నయ్య, టైర్ 1 ఇంకా టైర్ 2 అనేసి.
కాకపోతే మన టైర్ 1 నీ ఇష్టం, నువ్వు ఏదైనా యూజ్ చేయొచ్చు. అదే కలెక్షన్ 1
అంటే
కలెక్షన్
ఏది
2
యూజ్ చేసుకున్నా పర్లేదు అన్నయ్య.
ఏది యూజ్ చేసినా పర్లేదు.
ఓకే అన్నయ్య.
So ఇప్పటి వరకు till now we learned about the what we call NDVI. So now I'll tell you how to use how to analyze land use classification. So give me 1 minute, I'll drink water. So it is not boring, right, till now? It might be boring because it is taking a lot of time. I told you already it might take 2 to 3 hours. If you do it parallelly, like you will also learn, it will become a workshop for you.
Yes, Anna, it's very interesting, not boring, Anna.
Okay, I feel it. So we have calculated NDVI, have calculated FCC. So now I'll tell you how to choose training. What I tell, we need a training classes. So for that, I'll just remove the NDVI. So I'll have FCC values. So in this FCC, I just go to stretch of 100% and just apply it. Why 100%? For clear visibility, I'm using the stretch of 100%. So then I'll go to this polygon geometry value. So in this, I'll go to setting. In this geometry, I'll give a feature collection. See, this is a very important, and you must be see very carefully. So in the geometry, I went to settings, config geometry property, import as feature collection property. I'll give a property name as LULC. So this property is very important, and these properties use everywhere. So for whatever the geometry you take, for water body, urban area, whatever else, the property should be same, and this value is 1. Okay, the color you don't care about it, and the training color is different from the palette you will give after the classification. Those are different. So I'll give it as a water. So my training data for water, I'm giving this value 1, and then I'm adding a new layer, and this is giving as urban. Okay, so I'm classifying, and this is a feature collection property. Property is my LULC. It is same property, same for everyone. Don't change. If you change this, you cannot get the values. 2, and then I'll give my third geometry as vegetation. Feature collection property LULC value is 3. Okay, and another layer I'm adding, and for it is a Bangalore, so I'll just require 4 parameters. So feature collection property LULC. Well, LUL is basically land cover, value is 4, and okay. So now I have the 4 different training sites. So what I need, I just want to click the data. So you can clip it anyway, anyhow. You like whatever the way you can clip it, you can clip the training data sets. See, so see if I want to clip water bodies, these black things are water body. I show you in the slides the whatever the dark part. So that's why you use the satellite data background, and you can see the whatever the data sets. So you can see the like polygon, like you can see this polygon or point, whatever needed. But most for most accurately, you can use a point, this polygon drawing. So for time classes, I used only 2 polygons. So this is how you can do. Just click the with your cursor, you just go and drag the water bodies you find, and just give a right click and just click the water bodies over there. Okay, so I don't just give the polygons more, because I take the points and take here, because due to the time left I don't have much time. I just give a 10 points for everything to classify, and these points should be very random, not to be concentrated at a particular location. You give a number of points, but if you need more accuracy, this is basically these machine learning and deep learning is a data hunger actually. So how much data you give it, it takes very, like what we call, take it as food, and if you give more data to it, it will classify more and more. So I'm just putting random points. Just right click on everywhere the points. So I am done with the water, and then I'm going to urban bodies. So this is my urban area. So I'll just give different points here. So before that, I'll take like a particular polygon, at least 3 to 4, because for accuracy. So this is the training data I'm taking. So training data should be, if you are using the bands like 9 bands, if you, let's say you're using 9 bands, the training data should be 9 into uh, n, I guess 9n, I guess. So it is like 90, 4 into 9. No, no worry, you can take 30 classes for each band. So it is like each what we call land use, land cover. So it will be useful. So you can here point, you can say random points. You can choose random points. I'm using the points, but you don't use the points, because for time constraint, I'm using the points for classification. So for more accuracy, you need to take polygons instead of points. Points should be very random. Like it should be on the urban, but it should be very random. It should not be concentrated at one point. Being very random. Okay. So okay, in the bottom I missed. Okay, let's say these are my urban areas and vegetation. The red patch is my vegetation. Let's say I'll take few polygons. So this is my vegetation, let's say. So verify with your background data for all these things, because you don't have any other things to verify. So if you zoom out and zoom in, so you can see here the background is vegetation. I may not get the polygon. I'll take, instead of polygon, I'll take points. This is my vegetation, 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 vegetation. This is vegetation, 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 vegetation. Cursor is slow. Vegetation, 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 vegetation. So you're able to understand this, right? So
Yes,
we are
sir.
giving the just training sites for each and everything. So if you want to classify urban area, we are giving the training sets of urban area. And if you want to classify water body, we just extracting water bodies at training polygons. Actually, these are called training polygons. I'm just taking the points because we don't have much time. So the finishing off, if you have any doubts in the further, I'll be taking another class. But this is not a big problem. If you're so if you're classifying the things, you should be very accurate. Just zoom out, zoom in much, and then take the area of required thing. So it should be any shape. It should not be rectangle. It doesn't mean it shouldn't be any rectangle. So if it's urban area, like if you're taking the polygon, you can the polygon should be anything. But don't like don't what we call, if like if you are calculating for your home, what we call, you'll extract the whole home like point to point, but you don't do it here. You just take a random polygon and do it. And others now have to do for others. So the white patches here are the others, let's say. Okay. Just to take points. These are the other places. If it is not urban area, if it is not vegetation, if it is not water body, I'm just clicking it as others. So why this is FCC is useful? Because for this purpose, because if it is a national satellite, let's say if it is national satellite, we cannot identify what is what. Because of these false color composite, we are able to identify what is and what. So that's why this false color composite is useful for land use analysis. Okay, so let's say this is others. Okay, yeah, the merge points. Now see, let's say I log this. No need to log. Okay, done. I done with this my training data set. Say now see, you can see here. Yeah, I came with water, urban, vegetation, and others. You able to see, right? So water, urban, vegetation. So whatever the points I've added here, it be that you added 17 elements of water, urban is 14 elements, 45 elements of vegetation, others 25 elements. So I took the random. So you should be careful while taking the training data sets, because those are the important for you to analyze and classify your data set. So now I'll go to my PPT. So this is creating training polygons. We have created the training polygons, and then we need to select bands for classifications. So I need to select bands for classifications. So first, so I need to write, I don't even want to write the code. So I'll do one thing. So what need to do, selecting bands for data sets. So see, so selecting bands for training. So I have the bands. I told you that band one is for like coastal areas, but it's not a coastal area like aerosols and coastal. I chose from bands 2 to 7. So if you have any doubt, go to this section. So I already told the bands, like bands, we have the different bands. Band 1, band 2 to 7 are the reflectance value. Band 10 is the surface temperature value. So for these particular case, don't require this STB10 value. Only require B2 to 7. I'm ignoring the B1 because it is for ultra blue coastal aerosols. So now I have the selected bands. So then what should I do? After selecting the bands, divide the training polygons for classification and validations. So now I have to divide my training polygons for classification and validation. So for that, I have to write a code like, see, like the sample inputs image to get a feature collection of the training data. So let's say I'm taking a variable training of what? My image which is my clipped image from my data set, dot select, my selecting the bands, these bands, say variable these bands, dot sample regions. I'm sampling my regions of collection LULC features. Okay. Okay, particularly I don't have my LULC features here, but property is LULC and scale is 30. So what is this LULC features? So I need to have LULC features. What are these? Let's say I have a variable LULC features. Features. These features just merging these water body, urban, vegetation, and others. Let's say this is like water dot merge urban. So see, whatever you have given here, you should be in the same manner. The whatever the spelling and all the things, it should be same here, water, urban, vegetation, in the same manner, like same order. If you're giving first water and the merge, it should be water here. If you're giving urban second, then you should merge urban. Uh, then next, I don't want the code. Okay. Then urban dot merge. Then I had vegetation, right? Vegetation. If your code is right, it will show the blue color, or else it will show just black. Merge others. So these are the LULs features I have merged. And if you want to see this, you just print your LULs features to see whether these features are merged or not, or whether it's showing or not. Let's just save this and run this. So now I'm getting screen got stuck down. You're not able to see my screen. Hello? Hello? Pooja, you might have a little internet issue. So no problem. I'll be going on because it is already too much late. It's already 2 hours, like 1.5 hour while we started the video. It's the ending period, and you'll be able to understand no problem. So you don't. So still video is stuck for you. Hello,
Yeah.
Pooja. It's okay, right?
Okay, it's not good.
Like I'm not able to hear you. It might be from internet issue, little internet issue. No problem. So this is our LULC features. We have merged our water body, vegetation, urban area, and others. And we have like sample regions. We have collection LULC features. Properties is LULC. This property came from the property value we have given. See, let's this value. So this is the property value I have given here, and the scale is 30 meters. And see, I have the printed my LULs features, like see, column 2 features is 132. So it shows whatever you have this thing. Like 0, it shows the water, like property 1 is the water body, right? So the 17, like 1 is 17, right? 17 we have features. So 0 to 16 is, no, again 19, property 1, property 1, property 1. Feature 1. Feature 1, feature 2, feature 3, feature 4. So they are total 131, right? Total 131. We have class, like we have our training sets, and till now we have just merged our LULs features. So what are the training set data we have, and then next what we call and then we have to classify the things. For that we need a one training data, one is testing data. So we have we can take 60 to 70% of training data, and 30 to 20% of 30 to 40% of testing data. So training, what is the difference between training and testing? So in the training data, what we'll do, we'll take 70% of what we have classified. Let's say till now we have classified 100% of the data. In that 100% of the data, we'll take 70% for training, and let's say 30% for testing. In the training, what we'll do, we train our data with using our algorithm. Let's say random forest we are using right now. In the testing, what we'll do, we'll calculate the accuracy. So at what and how accurate we have calculated the how accurate we have classified our image. So with the 30% data, we will test our accuracy. So let's say I'll be pasting the direct code. So I can explain the code here. So it'll be easy for you. So now how see I have the bands here, LULs features, and have the sample input image to feature collection of training data. It's all done. So now I need a training data and a testing data. Training data and testing data for training and testing. Okay. So random selection of training polygons I have done. So let's say we have a variable with random. Let's say we are using random forest, and we have randomly chosen our training. So let's have a variable with random, and training dot random column of random. This is a code we are using for the training data, and we are splitting our data 70% for training and 30% for training. So I am splitting my data as 0.7 for training and 30% for testing. And let's say my training partition is with random, this is with random. I'm like say this is my training partition using with random dot filter. This is a function using dot filter e filter dot lt for training and lt for training partition and testing partition for GTE, and using random this random and splitting this for training split 0.7, testing by GTE the other portion, the other half for here 30% is here, we are splitting it. And then I need to train the classifier. It's a variable I'm using classifier e dot classifier dot using a smile random forest. Let's say we have the training data 100 percentage, and I'm training the data features. Having the training partition class property LULC input bands. So if you're not finding where he got this code, just everything is available in the doc section. Just click the classifier. You'll get this. Let's say I'm clicking the classifier. Like let's say smile random forest. See this is e dot smile classifier dot smile random forest. So e dot classifier dot smile random forest. So you can everything is available here. So for not for the time sake being, I'm not explaining everything, but you can see all the functions here. So if you really wanted to learn Google Earth Engine, this is the best platform. You can learn everything here without any guide also, because everything is available inside. So but for time's sake, I'm explaining the code itself. So we don't have much time. And class property, I have already LULC and input properties. What are the band here? And then I need to classify the input imaginary what, and let's say final LU. And this is a image, not plans array. Image dot classify the classifier, and using the different palette brands. Let's say for this is my urban using red color, and green is for vegetation. Okay, and this is my water using blue. But I'll put it in order because this is the first thing I chose. But no confusion. So blue, my water is 1. Urban is 2. Vegetation I chose is 3. And others is 4, right? And to display the same the map dots for adding the layer, map dot all layer, final LU minimum 1 and maximum 4. Palette, this is a palette color I'm using for visualization. And the last final thing is the AOI. Then I'll change this to not AOI, land use. I'll change to land use. Then I'll just before running it, just save it. You're able to see this, right? Hello.
Yes, Anna.
We are almost to final stage, so just run the code, and I hope. So you remove the geometry inputs for our sake. So you have the land use here. Okay, clear this, remove the FCC after classification, just remove the FCC. So remove the MDVI. Let's hope our classifier get good image. This is the classification what we are expecting. So you're able to see the screen, right? Hello.
Yes, Anna.
So it is easy, right? More than you're doing the Google Earth Engine. So this is the last final classification image we got. If you click the geometric inputs, these are the training data you initially took, and after taking the training data and writing a simple code, and then you are able to classify this. So it might took long because for me explaining all the things and trying this. If you do it your own, and you will get to, if you are familiar, if you are getting familiar with the code, it will take nearly half an hour for you to classify the things. Not little half an hour. If you have the code, just click run the code and just click the points or just take the training sample. So it will take you take the time for just training data only, because You have to take every polygon for each training data to classify. So now what we'll do, we just export it. So for exporting, I don't take much risk. Just copy this code and paste it. So now I need the images final LU, not this. Final LU, final land use, and description, let's say land use, and folder, let's say class 2, ATM, AY, scale 30, everything is fine. And then I'll just save it and run it. Go to taskbar. See, see, now I got land use one. Before I have land cover. Now see, I changed the description to land use. Now I got land use. Let's run it. Run this. So till now we have just classified our data. We didn't found any validation thing. Okay. So till now we just classified data. Whatever next thing is dividing training polygons done for classification validation. Next is the classification of image, define the color palette. So we have already classified our image. See in this code till here we have classified our image. Till this code, these few lines of code we have classified image, and this is the color palette we have provided. Okay. This is the color palette we have given. Say LU palette, this FF00. If you want to this, I'll show you the color how it will be given. And this is the final array. I have a minimum 1 because there are only 4, minimum 1 and maximum 4. Because we have classified only 4 values, minimum 1 and maximum 4. Palette is LU palette, and the final thing is AY. This is not the thing we have divided. This one, okay. And this one we have done water, urban vegetation, 4 values, minimum 4, and land use done. And I think it is land use open in drive. Library land use, this land use, download it. It might be downloading, and we'll go to till we have classified our image. We have trained the classified tuning is done, classification image is done, defining color pattern is visualizing the results is also done, exporting the classified image is also done, right? You clear with this? Hello. Hello.
Anna, yeah, Anna, it's very clear, Anna.
Okay. If you're not clear, I like if I say you're clear, let's say turn on the mic and say clear, because I don't know if you're clear or not. So till now we have done with the land use classification. So this is a simple code we have written. Okay. So not this one. So I hope it is downloaded. So I'll go to QGIS and just explain it here how it going to be done. Open the raster image. Okay. And land use one Bangalore. Add it. So this is the data we got. I'll just close this land cover thing. Go to symbology. Keep the palette unique values for this. For land NDVI, you go to single band pseudo color for this unit palette and let's just classify. So we got the 4 values, 5 y5 because I'll show you we have a background value and just apply it. See, we have this value. So do one thing, just click this and just click negative value, remove selected row, that will be row been gone, and just click on this. This will be the water body, right? Do one thing, let's say this is a project color and just add here the values. Let's say what are the values we have given for water. Palette value 000 ff this ff00, okay. Let's say add values like what I have given hashtag 0000 ff fluid scheme. Next, let me add here. Okay, let me add here so it will find. And next color is what? FF 1 2 3 4 0 zeros. Red. Add here and this 0 FF 0. Why this half here? Next color is whatever color left. 0 FF 0 0 FF 0 0. Okay. This next is 0 0 FF 0 0. Another color. Okay, I'm clicking this, right? No, white, green. Okay, let it be. You just add. This is the process how you can add your project colors. Let's say I show the recent colors you can add. But for what I have been using this color, let's say. For red, it is this one. For green, I'll use green color. Okay. For others, I'll use magenta or yellow. Okay, water is not blue. Well, I label it as water. I label it as urban. I label it as vegetation. And I label it as others. No spelling mistakes. I need to learn a lot. Okay, just apply it. See how whatever you classified here, it is here now. See whatever you classified here, it is here, right? Okay. And you can see the labeling also. Water, urban. So if you need to map these, just Control P and it's a land use or land LU, whatever you want. Give the name and just click OK. And you zoom. Let's go to page properties. If you A4 and landscape, if you fit with the A4, you just keep the A4 and go to this map option, add map. Just drag this and you will get your map, right? So if you want to zoom in, just go to this thing and just click it, zoom to layers. Or else you can change the scale here to 20,000, right? So this larger one. You just go to 2 lakhs. Or else you can use 1,15,000, 50,000. So you can change the scale 1,50,000, 1, 2, 3, 4, right? So or else it is still, it may be fit. It's large. I'll just stick to 2 lakhs, 4, 5. So you're done with the scale and you just add a label. Okay, label, let's say BBMP. So see, I'm showing the mapping also, so it can be useful. BBMP, let's say 2023. Then let's say go to font, change this to bold and give this value of 25, whatever you want, how much you require. So there's a basic thing. Well, I'll show you what are the basic things required in the map, and I'll add legend. So this is how you can legend. Just click auto update off, and then down only show that item inside the linked map. It will show the linked map, and then go down, go to fonts and texturing, item font, keep bold. Okay, so it will be bold. And subgroup font, keep bold and keep it 14. Okay, and sorry, and go down and just click this, remove this. You'll see how it will be removing. Or else if you want to in a single row, go down, go to columns and give a split layers. Count is 1, 2, 1, 2, 3, 4, 5. So just increase this. Hey, why not? Actually, you can use this also. Just do one thing, remove this land use one. Nice. Totally removed. But it should be come as a row actually. But I don't know why it is not getting. Okay, let it be. Don't split it. Be it. Then they just do auto update. So go down. Fonts are same. And let's say you can increase the font size or symbol. And don't keep background or frame anything for this. So you're getting right. Okay, spacing. This is how you can view. Right. So this is the basic thing I'm giving for you, and then you have to add a north arrow. Arrows, click it arrows, choose anywhere, anything. This is an north arrow, and then you need to add a scale. Scale, single box or double box, choose anyone. And you can use a fixed units, it is 5 or 6. Any unit you want, you can choose. 5, 4, 8, 3. This segment. So this is how you can do it. Fix it with the 5, let's choose like 2. Okay. So this is a basic mapping I shown you. So done with the mapping. So if you want to add any base layer, you can add this. Go to web, quick map services, OSM, open topo map. So this is how you can add any base map to this background. So you can add this and you can see this here also. Right, I'm done with this. So you're getting right? Are you clear? Hello.
Yes, Anna, very clear.
Okay, this is how we can done, how it could be done. So if you want to save this, save the layer project in somewhere and go to project and okay, not this one. Go to that thing where is a mapping. Go to map and save this layout. Or you first need, if you need to save the this project first, and then you can you can save this and this go to layout and export the image. Some WHS servers limit other get the so let's say JPG. I'll save on desktop as LUS PNG format. I hope it's saved. So till now you have understood how to classify and how to export and how to do the analysis, what we call how to export in QGIS and how to map a basic map. So I have shown till that, so you might not getting any doubts. This is the basic map we have created. So you're able to see, right? So far, this is 2020 Bangalore. So we have created. I hope you are getting clear everything. So if you need to add a shapefile around it, you just add the shapefile in the map and then you just map it. So that's fine. So till now it is okay. I hope so. Everything's good. So till now it's okay, and then this will be the case. We are getting land use analysis, and we have done this. And so the same procedure I'm showing again, creating training polygons. So okay, let's begin. So we need to, for land use analysis, we need to create training polygons. So we have created a four training polygons for urban area. So depending upon your study area and depending on the number of regions and number of like varied regions you have, you need to classify the things. So you have to create the training polygons according to that. If you have urban area, vegetation, water body, agriculture, or if you have bare land, if you have river network, you can do it as well. That or if you have open areas, shrubs, plants, or if you have a like what we call carnivorous forest or deciduous forest. Likewise, you can create your training polygons. And then these are the color palette we will be using. So for forest areas, so this HTML code you can type in the Google Earth engine, or you can give the red, or you can just give the yellow, green, red, magenta, and blue. Or if you type it like that, also it can work. So these are the standard colors you need to give for any any land use feature. And then we have the merged out training polygons in each and everything. I showed you LULC features, printing LULC features, gave over different data sets. And we have like selected bands from B2 to B7. And we have the sample the input imagery to get a feature collection of training data. We have done that. And we had a column of random uniforms for training data sets. And then we splitted our data set according to for training and testing 70% or 30%. And then we have the train the classifier using small random forest classification. And then we defined our color palette. And then we have displayed our map and we have export. Till this, do you have any doubts? Hello.
Anna,
Hmm.
Anna, that map is only for 2023, Anna. But if I want to get over a period of 3 decades, then what I have to do, Anna?
Then you can do it. See, for the I choose Landsat 9, so I'll show you. I'll go this browse this yes that. So this is I chose what we call Landsat 9. So see the date range from 2021 to present. So if you need an accurate value, so you can choose Landsat 9. But most of the people don't choose Landsat 9, they use Landsat 8, or you can use Landsat 9 also, it's fine. The data set range from 2001 to present. 2000 Landsat 8 ranges from 2013 to present. Let's say you want to classify your image from 1980 to 2020. Let's say you are taking for 10 years, like 1980, 1990, 2000, 2010. Okay, and 2020, let's say 5D. So for 1980, don't use Landsat 7 because you won't get the proper data over there. Use Landsat 5. You have data from 1984 to 2012. So you can use 1980 data, or else you can take like this 1985, 1995, 2015, and then 2023. Okay. No problem. It is not the 2025. You can predict the 2025. Okay. You can also predict the what we call the future analysis by using the other different algorithms. If you want to do really future prediction, and you can also do that, it will add some value to your project. So you can use, if you want to do, let's say 1985, use Landsat 5 TM. If you want to do 95 Landsat TM, the same procedure, you cannot do anything, but you need to change the band values because Landsat 5 band is different from Landsat 9. That's a sub tier 1 I'm using. I'm going to bands. See, here the SRB1 is band 1 blue surface reflector, but there is the coastal area. We neglect that the band 1, but here you should include band 1 to 7, and there is band 10 is thermal temperature, like temperature band. Here band 6 is temperature. So if you're reading your article paper of any journal or anything related to your project, if they are using land use land cover classification, they will explain you, like if you are calculating surface temperature, and they will explain you which band is they are going to use. If they are using Landsat TM, like Landsat 5, they are using band 6. If you are using Landsat 8 or 9, they are using band 10 or 11. So these are the basic bands they are going to be used. So no issues. If I am explaining 2023 Landsat 9, you can also do Landsat 5 also, because I'll be providing code. Just change here and there and it will be fine. If you have any doubts, you can ask me anytime. Okay.
Thank you, Anna.
So it's not finished yet. It will take more half an hour. Please listen. So I want to finish it at all today. And so what we left with, so till now we done with the land use analysis. So then we need to calculate the area of the each classes, and then we need to validate our results. So how accurate we have done till now. Okay. So for that, this is the accuracy assessment code. I'll just show the code first and then run it. So then, so what we done first, we took let's say we have 100% training data, then we took 70% for training and then 30% for testing. So for testing, we have the random testing partition to classify the training classifier. Then we run a confusion matrix to validate our data. So we run the confusion matrix for error matrix for our LULC, and calculate the overall accuracy, print overall accuracy and kappa statistics. So these are basically used for running accuracy assessment, and then you find to, and then we find the area of the each classes. And I'll go to my code. Let's say. Just I'll copy and paste it, because if I write it, it will become tomorrow, day after tomorrow. So I'll show him here. They classify the test feature collection. I'm classifying test is equal to, I'm taking a variable called test, and then testing partition dot classify the accuracy classifier, because we are using an accuracy classifier to find the validation. Let's say we are validating it, validation of the data. Okay. So, and then we have the calculating confusion matrix. If you find any general, they will be using overall accuracy or confusion matrix for the accuracy. And we are like, if you see my project paper previously, I have done in my my BTech project paper, there I also done this confusion matrix. There you can find is a box and the overall accuracy. What is overall accuracy? Producer's accuracy. It might be helpful. So I'll be just writing the code, and let's say variable overall accuracy. This is printing overall accuracy dot accuracy. Just printing overall accuracy for visualization. I'm just printing it, and then calculate the consumer's accuracy and producer's accuracy. If just read a journal paper, you'll get to know what are these things. And then I'm calculating kappa statistics for the accuracy, and I'm to calculate the area for each class. Calculation area for each class of classified image, because like how much area the water body occupied, how much area the urban area occupied, how much area the vegetation others area occupied. I need to calculate each of those areas. So I take a class area. Say if you want to find the any, just search the area. So this is a master area filter. So you'll get the same, the e dot image pixel area dot add bands final LU dot divide 1/6 dot by 1/6, because I want my area into square kilometers, right? So my resolution is 30 meter into 30 meter. Okay. So how, see, for 1 meter, convert 1 meter to kilometer, I require 1000, 5000, right? So I have 30 meter into 30 meter, like 1 pixel I'll show you what is a pixel means, so then you don't get confusion. I'll show, see this. Let's say this is 1 pixel. Come first. So this little green portion, let's say 1 pixel. So this little pixel is 30 meter into 30 meter. Okay. So I want this 30 meter into 30 meter into square kilometer. So first I need to convert 130 meter into kilometer. I do what I do by 1000. So it is 30 meter into 30 meter. 1 by 1000 into 1 by 1000. It is 10 power minus 6. Okay. So I divide it to 10 power 6. See. Image.pixel area dot add bands. Final LU image, classified image. We're dividing it to 10 power 6 and reducing image to some group one grouping one of geometry wise, giving the scale and best of it is true. And then print all class areas 12 kilometers and just saving it and running it. Let's see how it works. Basic classifier is 25, okay. Okay, some might be mistaken. I forgot to copy this also. But only I missed this accuracy classifier. But we have done this now. Okay. We are okay. Yeah, we first classified for the accuracy assessment. We are using the okay run. Let's see how it comes. I hope it works. You are able to see, right? There's no issue with the laptop extract and all, because this is the final part I'm teaching you, and we are going to end within 5 or 10 minutes, 5 to 7 minutes more, if it is run early. Hello.
Anna, everything is okay now.
Okay. So see, now see, the confusion matrix is, see, like 0 is my water body. So there is no error in this because everything is classified perfect. And 1 is my urban area. Out of 187 urban area, 185 is classified accurately, but 2 of them is classified differently. And 2 is my vegetation. Out of 264 is classified 264 is great. And 3 is my what we called what is my others, and it's one, and in that one is classified as others, and see, 366 classified is good and one is classified others, and 4 is the additional value. It's a no value data, it came out of range, and the overall accuracy I got 99.63%. Okay, it might be not accurate, but whatever it is classified according to the classified is 99.63 accurate. And you can see consumer classifier 0, 1 point is different. And you just deal with the kappa statistics. This is the accuracy, how much? 99.44% is accurate we done. And you need to find the like area of each thing. 0 is my water body, see 20.02 square kilometers. And 1 is the value of 1 we given is urban area, which is 370 square kilometers. And 2 is 281. Vegetation is 281 square kilometers. And